Very good afternoon, students. So, welcome to IIT and NEET Foundation or Focus C program of Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8 students for today's session. As you can see on the screen, my subject is physics. We are in class 8. Our ongoing chapter, pressure. Today we are entering into the session number 2. As you all know, we started this chapter on Tuesday. The first session completed. And today I am entering into the second session of the pressure chapter, right? So before that, let me remind you one thing about our test number 4. Test number 4, so far we completed 3 tests, 3 monthly tests. And we are now, test number 4 is on 28th of this month, 28 October 2024. Here important thing is the syllabus for this particular exam is cumulative. Total all the chapters which you have covered till now. Cumulative syllabus. Till now what you have done, the first 2 chapters, chapter number 1, 2 and 3 till today, what we have covered. Okay. That is third chapter is our today what we are covering, pressure. So the same pattern of paper, same number of questions, but covered from the 3 chapters. Remember, right? It's a gentle reminder for next. Still, there is a time is there, 10 days time. So we have the test number 4 on 28 October. Syllabus is cumulative. Not only in physics, in all subjects, there is a cumulative syllabus. The syllabus which is covered till the date will be appeared in the question paper. Right? Okay. Now we move to the today's topic. Before learning about today, we'll see what we covered in the earlier classes. So we can see beautiful GFs, gifts are there, pictures. So what we covered in the session number 1, you can see on the screen. Topics discussed till now. In last class, we discussed about what is a force. So what is the unit of force? What are the types of forces? And what are the example of force? You will be thinking the chapter name is pressure, sir. Why you are discussing about the force? So because pressure is derived from force only. Without force, there is no pressure. Right? So that's first you have to get clarity about the force. Then we can move to the pressure. Right? So force, you know already. Force is nothing but either push or pull. Push or pull on a body which either changes or to change, try to changes the position of a body or tend to changes the position of a body is called force. Push or pull, technically known as force. So many examples I gave for you. Then force is measured in units called Newton or dyne. Newton in MKS or SI system, dyne in CGS system. Right? So there are 2 types. Major classification is 2 types. One is contact force and other is non-contact force. Or is also called force at a distance. So contact force is the one which comes into play when the 2 bodies are in contact. A force comes into play when 2 bodies are in contact. Is called contact force. Frictional force you can take. Normal force you can take. Right? Spring force you can take. Which comes into play when the body is in muscular force. When you want to move any object, what will do? You hold that object and pull or push. That is muscular force. There comes under contact. For example, magnetic force is there. Gravitational force is there. Electrostatic force is there. They comes under non-contact force. Means they acted upon a body without direct contact. Right. So there are so many examples we discuss about the force. And again, you can see on the screen also pictures. when you are playing the game called tug of war, we start pulling the rope to show our force, right? You can see here. And the boy is pulling the car, pushing the car, how it is moving here. So in a tug of war game also, whichever side the force applied is more, that side you can move. Okay, this is everything about the force, right? So we'll see some more things about that. So what we discussed in the last class. Welcome, Falaknama, Masterminds, Jogipet branch. So we discussed about what is a force here. See, examples are a football lying on the center of the football court at the beginning of the game. Remains at the rest till a player is kicked it. Correct or not? When you want to open the door, either you have to push or pull the handle. Correct or not? So push is, what is push? Moving away from us. Push is moving a body away from us. You note this point also, synopsis, continuation for yesterday. Moving away. Moving away is called push. Or pull means moving towards. Moving towards. So both together called force. Technically called as force. Right? Then what is the effect of force? What force will do? I told already. Force will change the shape of the object. Force will move the object from position to rest position to motion. Rest to motion. Change the speed of motion. If you apply the force, what happened? You can increase the speed or decrease the speed also. So change the direction of motion. When you apply the force, you can change our direction. And also a force can stop the moving object or slow down them down. So all these are the effects of the force. So force can affect all this way. Change of size, change of shape, change of speed, change of direction. All this is the effect of force, which already we discussed in the last class. Then when you enter to the, again, types of forces we are discussing, contact and non-contact with examples. So contact force, muscular force and frictional force. When the two bodies in contact, suppose when you are walking on a floor, you are acted upon by a frictional force. If there is no frictional force, you cannot walk also. It is a nature's force, God-given force. If the force is not there, we cannot walk even one step also, it will fall down. Such a wonderful nature force which comes into play when two bodies are in contact is called frictional force. Then muscular force, the force of muscles, which we are using for doing our work. Whether you want to move an object, whether you want to do some any work, other work, we use the force. So when you come to non-contact force, we come across gravitational force. When you are dropping a pen here, see, there is no direct contact between the pen and earth, but still pen is coming down because of the gravitational pull of the earth. Such force is called gravitational force, which is non-contact force. Right? So examples are given for gravitational force here. Then when you come to today's topic, so we'll discuss about two important terms in physics. Mass, weight. Generally, in our regular terminology, we feel that both are same. We feel that both are similar, but they are not same. There is a big difference is there between the mass and weight. Right? Mass is different from weight. Remember, I give the complete clarity by end of the class. So mass is amount of substance contained in a certain object. Very important point you can note down for today, the first point of the day. Mass is the amount of substance contained in a certain object. Amount of substance. For example, you take 1 kg of sugar. Measure its mass here on earth. Or for example, in Hyderabad, you take same thing Vijayawada, or take same thing USA, Australia, UK, or you can go to the moon. Wherever you go, the mass remains constant. Because the quantity of substance is same. Substance that makes up an object is known as matter. As long as matter is same, unless you eat the sugar, it remains same only. Hence, mass is the quantity of matter. The unit of mass is kilogram or gram. 1 kilogram is equal to 1000 grams. Correct or not? So, mass is nothing but the amount of substance contained in a body. So, for today, you can write this point. And the units of mass are either kg or gram, where 1 kg is equal to 1000 grams. 1 gram is equal to 1000 milligrams, you can call it as very small unit. Right? So you can note that. So some more discussions we'll do about the mass. And so see, so what do we call this? The mass is the 2 points completed. The third point you can see here. So it is remains same. Mass remains constant everywhere in the universe. Everywhere. It doesn't change. Next one is, it is measured by common balance. Common balance used to measure the mass. What do you use? You might have seen common balance in vegetable markets or kirana stores and all, which measure common balance. Correct or not? So mass is a fundamental quantity, as you know. It is a fundamental quantity and it is a scalar quantity also, because of only magnitude, no direction. So there are 6 points related to, and of course it's measured in kg gram is given there. Okay, so mass is the quantity of substance contained in a object. It is measured in kg or gram or milligram. It is remains constant everywhere in the universe. It is common balance is used to measure the mass. It is a fundamental quantity and scalar quantity. Right, you note all these points. Later I'll give the table also. Yes, you have completed, move to the next part. So there are 6 points we discussed about the mass. Now we'll see what is the difference with weight. Right? How far the mass is different from weight, we'll see now. Clear? Right. So now when you come to the part of second part, weight. All objects have mass because matter is there. Where there is a matter, there is a mass. Either it is liquid, solid, gas, or plasma, or anything. Every object on the Earth's surface is pulled towards the center by gravitational force. You know that Newton's observation from apple falling from the tree, a gravitational force is discovered. Right? So the gravitational force pulling the object towards the itself is known as its weight. So what is weight? Weight is nothing but the force. So You can write about weight, first point. Force with which body pulled. What happening here? Pulled towards earth. So what happening? Every body is pulled towards earth. Right or not? Every body is pulled towards earth by the force called gravitational force, which is called weight of an object. So weight of object is purely depends on the with what force earth is pulling. So see, on earth, the value of G. So you know acceleration due to gravity. Suppose I am taking this pen. The pen is at certain height. Its velocity is 0 now. There is no velocity here. But when I am dropping this pen, it is pulled towards the earth with some acceleration. There is a change in the velocity. That change in velocity takes place because of the gravitational pull of the earth. That is called acceleration due to gravity. So the acceleration due to gravity changes. So weight changes from place to place. It is not same. Changes from place to place. It is not same like mass. Changes from place to place. Because see, G value on earth if you take 9.8 meter per second square. G value on moon if you take moon, right? So that is 1.67 only. It is very much less than the 6 times less than earth. G on sun 27.4. This is 3 times more than the, you can write down this third point. So why there is a change in the weight? Suppose your weight is 60 kg. So my weight again, example, my weight is 60 kg on earth, right? 60 kg on earth. If I go to moon, my weight will become only 10 kg. Can you imagine? Why? Because the G value is less. It is 9.8, it is 1.67. So G on moon is 1/6 of G on earth. Nothing to surprise, our weight won't decrease, but it appears like that because of the acceleration due to gravity, because of the gravitational pull of the earth. Suppose if I go to sun, it is very not possible even to imagine also, because you know how hot sun is. If I go to sun, my weight on sun is 180 kg. If my weight is 60 kg on earth, it becomes approximately 180 kg on sun, if I allow it. Because you cannot go to the sun. If you go to the sun, it becomes ash only. But for mathematical calculation on paper, we can do like, why this is changing? Because of change of G value. So the weight changes from place to place due to changing the value of G, the value of acceleration due to gravity. Got it? Then, so 1 to 3 points completed. When you come to the fourth point, here after 3 points, fourth point, the weight is given by W is equal to mg. And weight is measured in Newton because of force only. It is measured in either Newton or Dyne. I told first only. Force is with which body is attracted towards earth only. That is force only. Force with which body is attracted towards earth is called weight. So weight is force only. Then force is measured in same. Right? So force is a derived quantity because it's derived from mass and acceleration. Derived quantity. So because it is attracted in a specific direction, it is a vector quantity, not scalar, vector quantity. Right? So this is the 7 points about the weight. Force with which body attracted towards the earth. Towards the earth is called weight of a body. Right? Towards the earth is called weight of a body. Just a minute, let me clarify. Right. Changes from place to place. So you note these very important values. So G on Earth is 9.8 meter per second square. G on Moon is 1.67 meter per second square. G on Sun is 27.4 meter per second square. Right. Now the weight is given by the mathematical formula. Even mass also you can write. Mathematical formula W is equal to mg, mass into acceleration due to gravity. And it is measured in Newton or Dyne. Newton or Dyne. So it is a derived quantity. It is not fundamental like mass. It is derived and it is a vector quantity because you have both magnitude and direction. Clear? It is measured by, another is the 8 point. It is measured by spring balance. You might have seen the spring balances. If not, I request your teachers to show you the spring balance. You can find like this simple way with one spring and looks like here hook will be there. You can hold the object here. Inside that there is a reading. So whenever the body is suspended here, we can get the weight in newtons. Right? Spring balance. Common balance for mass, spring balance for weight. Right? So weight is nothing but force only. Force of Earth. Suppose on Earth 9.8 meter per second square. But it is not same throughout the Earth. It may slightly changes. Suppose your mass in Hyderabad is 9.8, sorry, 60 kg. When you go to America, it may become 59 or it may become 61 because of the change in the G value. Slight changes will be there from place to place, depends on height, depends on depth, depends on surroundings, temperature. All these surroundings, environments affects the G value slightly. It may from 9.7 to 10. That's all, not much change, like Moon and Earth. But there is slight variation on factors called Earth, that is depth, height, surrounding positions, and all will affect. That is temperature. Everything will affect the G value or weight. But mass does not affect all these things. Nothing will happen. Okay? That is about the mass and weight. Clear? So I move forward to one more clear explanation. You can note clearly. 5 points are given here, or more you can add. You copy this table as it is. You can add some more also what I told. So many things you can add here for this. So I'll tell what to add. First you note is 5 points. Table. Okay. So many things are there to note here. So I'll show you one video also for you after this, before closing the session. In this only 2-3 points you can add, then you can right. So there I can write here on 6th point. Common balance. You can add common balance. We'll use common balance. Here you can write 6th point, spring balance. I'll clear later. Not so clear. I can show you in some next page. You can add already you written spring balance, common balance, and fundamental quantity, derived quantity. scalar quantity, vector quantity. Formula W is equal to mg. You can write for this also. M is equal to F by F. So many things you can write for mass also. Again, M is from F is equal to MA, you can write M is equal to F by A. From formula of density also you can write mass, you can find out. Anyway, after writing this, I'll show you one video for you regarding some clarity about mass and weight. Even though both the terms appear same or sound same, there is a big difference is there, as you have seen now. Nothing is matching. Everything is different only. Right. So you can see the video now. Just keep watching the screen. Okay.
Is to confuse mass and weight. The two are absolutely not to be confused, but after watching this video, you will never confuse the two again. First of all, the reason a lot of us mix between the two is probably because we use the unit of mass to measure weights in our daily life. For example, if I weigh 75 kilograms, when I step on a scale, I'd say I weigh 75 kilograms and that is my weight. Now notice the language here. Weigh suggests that we're talking about weight. Then you go to physics class and you get told that kilograms are the unit to measure masses. And that is true. So what is the difference between the two? Let's start by saying what mass really is. Now mass is the amount of matter in an object or a body. It's the quantity of matter in something. These little building blocks that make an object, how much of that is in it? Quite literally, your mass is how much of you is in you. Now the mass does not change and is always the same. Weight, on the other hand, is actually a force, and it is the force that gravity does on the masses. When we stand on the earth, the gravity gives our mass its weight. The fact that we exist in a gravity field causes us to have a weight. Now mass is always the same and it doesn't change, but weight can change depending on the gravity field. For example, things weigh less on the moon than on the earth because the moon has smaller gravity than the earth, but the mass is actually the same in this example. The fact that I weigh less on the moon doesn't mean that I am physically smaller on the moon. My mass stayed the same, but because the gravity changed, my weight changed. If I am a really fat person and I go to the moon, I would weigh less, but this does not mean that I am less fat, because I haven't changed. I just changed planets. I know, the moon is not a planet. Anyway, the statement that I want you to remember is that the force that is done on a mass does not change how much the mass is. Now, let's take a look at an example and an analogy that's going to explain that much better and just help us visualize this concept that I'm trying to explain here.
This is an ice cube, and we know that water or an ice cube is made out of molecules, and the molecule is 2 hydrogen and 1 oxygen, that's H2O. Now, for the sake of the explanation, let's just say that this ice cube has 100 molecules of H2O. 100, exactly 100. In it right now. That's going to represent its mass. If I take my finger and I push it like this to one side or the other, what I essentially did is I applied an external force moving it from one side to the other. Now this does not change the fact that this has 100 molecules of H2O like we said earlier, because it's just a force that's applied to it. Evidently, there is always a force that's applied to it, and that is the force, of course, of gravity. So the force, whether it's my finger or gravity downwards, does not change the mass. The mass is simply how much H2O is inside this ice cube, and that's always the same. Of course, provided that it doesn't melt, but this is just for the sake of the explanation. And there's always a downward force that is for gravity. And this force of gravity that's acting on the mass is the weight.
So that is about the very important concept in physics, that is in especially in chapter mass and weight. So we are very clear about the mass and weight by now, and there are some more forces discussed here about the magnetic force. When you are discussing about the force continuation here, magnetic force is there, electrostatic force, which are the non-contact forces. Which are non-contact forces, the force of magnets, the force of the poles of the magnets. You know, when you take the magnet and place some magnetic material near, without direct contacts also, the magnetic material will attract towards the magnet. So that is there, it's called as non-contact force. Similarly, electric charges. Yesterday we have seen one video when you are combing your hair. After combing, the comb will attract the small papers because of the electricity, static electricity produced. Right? Clear? So with this, we are completely done with the topic force. Force, types of forces, mass and weight. Right? All these completed. So next, when you go to the next class, next week, we'll enter to the synopsis 2, that is with pressure. It's our major topic. Right? So what is pressure? Where it is applied? What are the principles of pressure? What are the application of pressure in our day-to-day life? Because the pressure is a commonly used word. When you are exam time also, you feel I'm getting pressure, I'm getting stress, I'm getting trust. What is that? That is nothing but a force only. When your parents are having a lot of expectations on you, or your teachers are pressuring you to get 10 by 10, that is called pressure on your mind. That is the pressure only. Means the force acting on your a particular area is called either trust or pressure or stress, common. So pressure is directly derived from force only. That is the reason before knowing about pressure, we learned about the force and types of forces, and we learned clarity about the what is the difference between the mass and weight, which is helpful for you in the next topic. Okay. So in next class when we meet, we learn about the pressure and some solid examples on pressure and everything, right? So before that, just you can add here. We have written the 4 points on mass and weight. I will add some more here about the mass and weight. You can add mass, weight, right? That is there. 5 points are there. Before closing the session, I'll take. So 6th point, measured by common balance. Measured by common balance. 6th point. Here it is spring balance. Measured by is the same only. Measured by spring balance. Right. So 7th point. It is fundamental quantity. It is a fundamental physical quantity. And it is a derived physical quantity. Derived quantity. Right? So it is 8 point, it is a scalar quantity. Here 8 point, it is a vector quantity. Clear? Now when you come on 9th point here, it is given by mass is equal to force by acceleration, whereas 9th point here, W is equal to mg. Means there is you can write 9 differences, are many more you can add also. Differences between mass and weight. So when you ask for the mass and weight, you can write the okay. Even you can draw the diagram also for that. For example, common balance looks like this. You know, this is a common balance. Vegetable market and all you can find a spring balance look like spring. Just like a spring only, you can see if you have any branches, I request the teacher to show the students how spring balance will be. There are some readings inside in newtons. 1, 2, 3, 4, whatever it may be newtons. There's a hook here. So when you add the weight here, it is pulled towards the earth and right. So like that, there are 9 points you can write, 10 points you can write for the both mass and weight differences. The both are simple words, but you can find the so many differences between them. Okay. If you have completed, we'll close the session with today's homework. We'll continue the same in the next session, that is next week we'll get again. You can take this as even project also. Write on chart and you can paste it in your classroom. And when you can prepare the chart on the forces also, types of forces. So many types of forces, you can get so many pictures, how I showed in the beginning. The pictures you can correct colorful pictures and you can paste on charts and display in the classroom. So that classroom will be scientifically colorful. Right? So good to see Jogipet, Talur, Indresham, Gudi Malkapur, Palaknama, and ECL branches. Right. So thank you very much. All of you have a wonderful day. So you can see the homework there. Differentiate between mass and weight. So what just I given, you make it clear in notebook, your target notebook or your IIT notebook, and take the signatures from your respective class teacher, subject teachers and parents. Okay. Note down the homework and complete that. Already completed, make it clarity. Done. So thank you everybody. Have a wonderful day. Thank you.